Welcome to Applied Day 2017. This is a series of webinars that Applied Engineering gives each year to share with manufacturing, engineering, and technology industry. Not necessarily the future of technology, but what is currently available to be implemented in your organization. Applied Engineering is here to help with today's challenges, and so I would encourage each of you to check out all the presentations to get a full picture of how we're helping our clients. Some of the other sessions, so this one is on manufacturing dashboards and the Internet of Things, but some of the other sessions are data management, ERP integration. We've got a very interesting customer testimonial tomorrow. Also, we're talking about electrical design, and we wrap it up with a presentation on Autodesk Fusion 360. My name is Aaron Sorensen. My background is in IT with about 15 years at Microsoft and helping customers select and deploy enterprise software. I've been with Applied Engineering for about 3 years, and my responsibility is in the area of IT, helping our clients with IT and software questions. Presenting with me is Steve Thompson.
Good morning. I hope everyone is ready for the day. Should be a good time. I'll just kick off something real quick here. We'll just talk briefly about Applied and kind of what makes us unique. And one of what we were told by a marketing company, because we didn't know, we're all engineers. So we went out and asked what makes us different. They asked our customers, they asked us, and they interviewed us, and what they came up with is 3 things. One is talent, technology, and adaptability. And kind of what the top talent refers to is Applied has a little bit of a unique business model, whereas all of our staff is permanent. When we're done with projects, people are just reassigned to new projects. So everyone, they have the stability of having a good long-term career path with also the variety that they're looking for to be able to get new and better, unique experiences. And so that helps us to attract and retain better staff. And so that snowballs into being able to provide better talent for our customers. And then technology, we work with everything from, being a VAR for Autodesk to we work with Creo, we work with NX, SolidWorks, FBA analysis, all sorts of different things. And that adaptability is just, we adjust to what our customers need. We can do things on-site, off-site, short-term, long-term, intermittent, whatever works. And so we just want to make sure our customers are served to the best of our ability and we provide a good value. So that's
Okay, so actually one good way to learn about more about Applied Engineering is on our homepage of our website. There's a great video there that will explain a little bit more about the background and the kind of services that we offer. And as you heard from Steve, Applied Engineering is really here to bring our expertise and our talent to help you solve your problems both of today as well as into the future. And we can do that in a way that helps you bring you the best talent, the best technology in a way that's convenient for your organization. So our topic today is manufacturing dashboards and the Internet of Things, and we'll be talking about some of the following topics. So in our professional services roles, Steve and I, we speak with customers every day who have challenges that affect the efficiency of their business. And sometimes the answer is people and skills, and we certainly have that. We've got lots of engineers and software developers. Other times the answer is the introduction and deployment of technology to automate, collect, and then report the data to measure the effectiveness of each of those processes. So let's talk about that kind of one step at a time here. So let's go through a little bit of history of a product that maybe everybody's familiar with. So here's a thermostat that everybody has in their house. It's a very solid product. Everybody uses it. Everybody knows how to use it. But the challenge is it had no connectivity, it had no flexibility, and it was just a static device. And it connected to your furnace, but that's the only place. And so you would set it once, and that's the way that it was for all time. And then we've made the advancement to a programmable thermostat, such as this one. And everybody can remember the days when you could program your thermostat to have a different temperature setting, maybe 4 times a day, and have a different setting for the weekdays versus the weekend, and that made huge strides. But it still had really no connectivity to anything outside of itself and connecting to your furnace. So now we're in the Internet of Things, meaning that not only are these devices connected, such as this Nest thermostat, but also so it connects through the Internet to your phone, to other devices, and allows you to set it remotely, view the temperature remotely. But it's also a learning device, meaning that over time it will learn your patterns. It'll identify when you get up in the morning and when you want the temperature raised and what your comfort levels are and what you want for a specific day, when you come home at night, etc., those kinds of things, and when it can be turned up and down. And it becomes a much more powerful device because it's learning how you live and adapting itself to the way that works. So how does this, how can we connect this to other applications? So let's take a look at an example. It's not just been the thermostat that's been a connected device, but other things in industry, such as an ag seed monitor. This is a very important device for farmers. As they're planting their crops, they want to optimize how the seeds are planted in the ground, whether it be for soybeans or corn or whatever the case may be. That's a very expensive item for them. So they want to monitor that they're putting that down in the best possible way. So this is an example of a connected device. And here's the monitor up here in the upper right-hand corner. And you can see all the connectivity, but the challenge is that these are all physical connections. And I think I counted these physical connections, and there was like 30, 31 or 32, something like that. And you need, in order to make this work, they all needed to be well seated, no moisture in them, no dirt, and it was a real challenge to make sure that this was all working correctly. The same is true in a manufacturing environment for monitoring the process. So the seed monitor, it was an example of a product embedded in, having technology embedded into a product. PLCs are an example of technology embedded into a process. And again, it was a wired connection and needed to be maintained, but still collecting really good information. So then how does that relate to the Internet of Things, and what is the Internet of Things? Well, you can think of it as this kind of a complicated definition, a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people. That pretty much encompasses everything, and that's why I included the definition as being, it's a meaningless term. The reason is that any kind of technology now is, nearly all technology can be connected in some fashion, whether that's through Wi-Fi or a wired device or something like that. So if you think of any kind of a new device, it likely has the capability of being connected. And so if it is an interrelated computing device, whether it's on your person or whether it's tracking your animals or whether it's monitoring something that's a part of your manufacturing process, if it could be connected in some way, then it can be part of the Internet of Things. So it's all encompassing. So here's my question that I asked myself: why this explosion in the Internet of Things, and why is it now kind of all ever present? One of the reasons is the deployment of very reliable and cheap hardware, and so Wi-Fi now has become really available everywhere, and it's very predictable, very reliable, and the hardware that is available is becoming less and less expensive, and we're finding that any kind of new technology, any kind of a digital device, that most of them now will have an API or a programming interface, which means we can collect data and then we can connect that, and we can collect that data and then deliver that to a central location. So some examples would be this. It's kind of an all-encompassing example of a mine where we have different devices and different protocols where we're collecting data, whether it be wireless or connected devices. And the possibility here is that you can monitor and control vehicles in this kind of a situation, so you can know where your vehicles are, you can identify what's going on inside the engine, those kinds of things, safety concerns. You can also monitor and control environmental data. Down in the mine, you might have be monitoring environmental or oxygen levels, and if that reaches a low point, then you can change the ventilation process and pump in more oxygen, as an example. You can monitor personal safety, and you can have a immediate response to any kind of safety concerns, any kind of personal health concerns. You can also monitor and report things like security breaches or just on-premise security concerns. And in fact, you can monitor and control production. I think we'll talk about one of those examples later on, where you can adjust the feed levels based on other environmental concerns, other productivity concerns. So one thing that we want to do is we want to bring to you what is real and available today. So this might be an example of the Internet of Things in a manufacturing environment or a real production environment. Many of the presentations of the Internet of Things are visionary and they're future-oriented, and maybe they seem like they're out of reach. And while that's good, what we're concerned about here is with our clients, our customers, and applied engineering is really here to help you with what you can do today. So with that, I think I'll turn it over to Steve, and we'll talk about some of the challenges in a manufacturing environment with Internet of Things.
Thanks, Eric. Well, one immediate challenge that comes up with manufacturing, from my experience and from walking around different plants, is there's a lot of companies have a lot of different equipment on the floor. There could be brakes, there could be different feed augers, or even welders or different things like that that are available, that are maybe they're in the critical path of what your equipment is or what your process is. However, they're not wired per se. They don't have the infrastructure. They don't have the feedback going back to a central computer. Maybe maybe the brake is 25 years old or 30 years old, works great, but you don't have any kind of, other than a depth gauge or something on it, you don't have any kind of feedback. But you know that that's a critical piece of your infrastructure, and it's something that has to take place in order for, you have to gather data from that in order to measure your efficiency or your productivity. Same with the feed auger. It might just be an on and off thing, but maybe there's no way of knowing if the auger's actually moving product or things like that. Or welders, maybe you know from your processes that, if we go through a roll of rod, a roll of welding wire every 2 days, that's, we're doing good. But so there's things that are just not integrated into a system that, modern technology, stuff that works just fine, but you can't gather any data from it now electronically. Go to the next slide here. All right. So a lot of times people accommodate for that, and they might take well, what I've done in the past is I had a walking route. And so there's different places that I would walk by that I'd have a path that would be, that's not me, by the way. That's just a model we took the picture of. There are different walking paths, so you could go down and say, okay, yeah, I went by, the product's not getting backed up in this area, but we got 2 skids that need to get pulled from this area in order to get, it's backing up here. And so then you adjust your process accordingly, maybe move somebody around to a different spot, or a whole number of things. You could be doing manual inspection of a product. Maybe you're writing down, thicknesses. Maybe you're writing down temperatures. Maybe you're going around and doing actual measurement. Well, those are all opportunities that the Internet of Things, and like Aaron was speaking of, the cheap hardware that's available now, the technology with Wi-Fi, that you can start collecting that data. Example of that is, the different sensors that are available. I don't know if you guys have followed too much on if you read much on the autonomous vehicles. One of the big players, or one of the big things that are pushing that, is the ability, or the sensor development. The sensors that are available for, LiDAR sensors, all sorts of different things that are being incorporated to those systems it's just amazing. So for instance, if you want to measure a process, I don't know, maybe you want to if you want to check on the brake, you want to know how many times the brake is slamming every day. Maybe you have a proximity sensor that measures something when it cycles through on your wheel, or maybe it's if you're measuring something and it creates some kind of heat, maybe you just have a heat sensor on it, then at least it's under use. Safety is another one. You could use a decibel meter. Maybe you're having some problems out on the floor with, people are saying, hey, it's really loud. Well, you could install some decibel meters, put it on some cheap hardware, have that signal Wi-Fi transferred over to a system that we'll talk about here in a minute, and you'll be collecting that data. So people, yeah, you're right. You got up to 110 decibels. That's too high. Or, you could have it at different spots during on the floor and be able to check that and continually monitor it. Or just, optical sensors as far as, if someone passes through an area, maybe it's hazardous gases, environmental things like humidity, temperature, any of those things can be very quickly monitored and worked up. The system is actually really, we work with a system that we can rapidly prototype. You say a few different sensors out on the floor, transmit that. Within a day or two, we could be testing and see if that's the data you want to collect. You can analyze it, understand if that's the system. If it's not, we can move it to a different area or some other different sensors. Or it's pretty amazing because you can collect this data in real time. There's not, if you want a ruggedized system that's going to, be very, reliable long term, yeah, you're going to take a little bit more work. But to test out the proof of concept, you can knock that out in a couple of days and be collecting data. So it's pretty amazing. It's fun. It's kind of an eye-opener because you start to realize, wow, I could get this data, or this would be, very beneficial to the company. So, all right, so now you're collecting all this data that you didn't know from, a lot of your machines are already going to have some kind of a feedback loop, whether it's a CNC or if you're getting information from PLCs, what have you. And so now you have that data. You have some other data that you're collecting on some non-integrated equipment. So you have all this stuff. Now, what are you going to do with all that information? Well, most of it rolls into, as I'm sure a lot of people are intimate with, is how are the key performance indicators of the organization working? And that's what it boils down to. I know every company has several. It could be, at the highest level, it could be revenue, profit, sales, productivity, all sorts of different things. And so they're kind of the ingredients of what we have. And so you have all these different pots, and typically, well, it depends on your company, but you might get a report once a week, once a month, once a quarter, and tell you how you did a week ago, 2 weeks ago, 4 weeks ago. So you're looking backwards all the time. And those systems are coming from a lot of different areas. And it's great information. It's good data because you can't, unless you're measuring it, you can't manage it. So it's something to keep in mind. But unfortunately, it is looking backwards. It's not real-time data collection, or I shouldn't say real-time data collection. It's not real-time analyzation and reporting. Is analyzation a word? I don't think it is a word.
It is now.
It is now. We just made a new word, analyzation. So anyway, so what you want to do is integrate all the different systems, when you mix these together and start pulling this off, this is where it gets extremely powerful, but it's not something you can just kind of willy-nilly it, because you're pulling information maybe from an accounting system, maybe from your MRP system, maybe from whatever else you have out there, different pieces. And so what we're finding extremely popular, both in-house and with our customers, is taking this information and make it into a dashboard. And so, and if you're familiar with dashboards are a lot of times, the key performance indicators, the KPIs. And so you may have different roles are going to want to see different things. So for instance, the chief of the boat or the CEO or whatever you want to call him, he may want to be looking at the sales, he wants profit margin, sales forecast, different things like that, because he wants to know what the numbers are at and where they're going. Well, if you're a manager, you might want to know, hey, what's the efficiencies? What's the output? What are some other issues that are popping up that we want to take care of? Maybe it's how often the machine's working, production output, things like that, things that control the things above the inputs for the profit and revenue. But maybe down on the floor, maybe you want to just see, hey, how long has it been since we've, had an injury, or how many products we're going to have to ship out on this shift, or what's the outlook looking for different things, or maybe there's an employee meeting that's going to be coming up, and you want to just demonstrate, have that up there on the board and say, hey, at 3 o'clock today we're going to have an employee meeting in the lunchroom. Different things. So different data needs to be distributed. Handed over to different people. And so that's pertinent to them. And so with this dashboard and integrating that, you can use software to produce these different dashboards that are web-based, real-time, and can be adjusted for whoever's doing them. So executives might get the first dashboard, managers, shop, they all get the different one, depending on where you log in, how you log in. It's all controlled, so you pop up, you go out on the floor, you log in on there, and the shop one pops up. Executives have a different login, it pops up, and that gives them their dashboard. So instead of waiting, a week, a month, or two weeks, or whatever, to get this report to find out how you did, you can get all this information real time, which, if things aren't going well, you can make corrective actions right away rather than waiting to find out that, oh, you know what, our productivity's been down the last 4 weeks. Well, you lost 4 weeks of productivity. So it's a real, very, very powerful tool. In addition, you can also color code everything. So for example, at the any level for that matter, if their profit revenue are all good, they can all be in the green. If they're getting close to your points that you want to make some corrections, maybe they're yellow, or red if they're not going right. So you could quickly make a visual check and know right away, yes, everything's on task, or no, there's some things to address. So very powerful real-time tool that incorporates data from many different areas, all integrated into one system.
And I think one of the opportunities for dashboards is that it can be a centralized way to inform everybody of their pertinent information. It allows you to educate, to how a picture is worth 1,000 words. It allows you to educate your staff on things that are important, and it also allows you to motivate like the dashboard that's up right now, motivate people to achieve their goals and work productively.
So let's here's an example we thought of when we were doing this, and it's kind of a cool deal. So take, for instance, if you have you're moving material, whether it's dirt or what have you. We'll just put up the picture here. So say you're moving dirt, and occasionally your system jams up, and then you have to shut everything down, dig it all out, unjam it, whatever, until you can get it rolling again. Well, here's an example of what you could do with some, if you will, Internet of Things technology. So you could be measuring your input feed drive, if it's a conveyor or whatever going into a hopper, and then an output conveyor. Well, you could have sensors within that hopper that measures, what height the hopper is full to. So if it starts getting too full, it could slow down the input shaft, and so you're not going to be piling up material so much. Or it could speed up the output shaft or conveyor to get it moving out faster. Different things like that. Then in addition to that, maybe it opens up the hopper door a little bit wider so things can move along. So you could be, instead of having a jam, you could actually be doing some corrective measures to control that, so you don't end up with the problem in the first place. And then in addition to that, you may have some suspicions that, this happens, quite a bit when the humidity's higher or the temperature is real low or different things like that. Well, you could be measuring that information at the same time, have all that data correlated, so you could look back and say, yeah, we had a jam here, it slowed down here, the humidity was 82, over 80%. Oh, this happened again. We've never had a jam under 80% humidity. So you're starting to dig into that root cause analysis, so you can actually get the data so you could make an informed and intelligent decision based on real information. And so maybe you can make the problem go away altogether. And I think that's everyone's goal, is to, when there are problems, is to fix them once, fix them right, and take care of them. But if you don't have the right data, it's pretty tough to, you're just kind of trial and error. And although that works most of the time, it's not necessarily as efficient. And as everybody knows too, it can get kind of frustrating when things are changing that you don't even know are changing, and you're trying to react to them all the time. So it's a little more proactive way of looking at things, and it can be pretty powerful.
So I think one of the things we talked about was learning devices. So Steve, as you mentioned, it's important in a critical process like this to collect data so that you can understand what's really going on, and you don't have to just think about it after the fact. So you can have all the data, whether it be humidity, temperature, type of material, speed, those kinds of things. And then, as we talked about learning devices, in fact, you could develop a learning device up and down the manufacturing process, or this process, and it could interrelate. So the speed of this conveyor could affect and its proximity, the load, et cetera, could affect the manufacturing or the distribution process all the way up and down the process. So these prototypes, examples can turn into learning devices that then can really optimize and make the entire process that much more efficient.
Yeah, and this technology is available now, and so that's what's really cool about it. And obviously a lot of us aren't moving dirt on conveyors and hoppers, but if you think about it, if you have a production line that maybe there's a couple different projects or sublines that merge into one line, and you're having trouble balancing some of those, maybe you can throw some sensors on there and see what the pattern is, and so maybe you can start to uncover what's the holdup. Maybe it's, hey, you find out that, yeah, this machine's jamming every 2 or 3 hours. It's jamming for some reason, and then all of a sudden it's a cascade of effects that go after that, and it snowballs all the way down to having not enough product getting out to the truck at the end of the shift. So that's the kind of stuff you can start to measure, and it's It's passive measurement, so you don't have to constantly be doing it. It's just collecting the data and holding that data, so you can look at it when you have time or when you need to. You don't have to have somebody standing there with a clipboard just logging data constantly to try to get that. All the human errors out of it, all the labors out of it, you just collect the data, and then you can use your intuition and the information that you've gathered to figure out what the solution is.
Well, I think we've given our audience lots of things to think about. We have time for some questions, and you're welcome to submit your questions now into the question box, and we'll answer them as they come in.
Yeah, in the chat area is probably the easiest way.
So one thing that we were thinking about is the question that we often hear: how do we know? Steve, how do you know what to measure? Are there some ideas about what you might want to measure?
Well, that's a very good question, because we run into some companies that there's the technology has not been available realistically to be able to do the measurement. So they have, it's tough to know what exactly you need to measure. It's like, that there's a lot of good information out there to find, but how do you know what's what? What are the key factors? Well, the prototyping helps for that, because you can start to collect data. But typically, from my experience, is you start with the critical processes. Every company has certain work cells or processes or equipment or machines that is, everything flows through that area, and it's usually the most tightly analyzed anyway. Maybe there's some different things you can start collecting in those areas, and then some basics of output or different things like that. Inputs, outputs, conveyor speed if that's variable, different things like that. But it's tough to start to identify what those KPI are. But in some cases there's already KPI there. You just measuring them in different ways. If it's a manual data entry or logging, writing down, or things like that, that's a really good place to start, because you can quickly go, okay, yeah, that's how that's being handled now. Let's get the manual system automated, so at least they don't have to do that, because I don't know a lot of people who like manually entering things to begin with. Usually the data tends to get not quite as pure as it could be, and so that kind of becomes a sticky point. Another question that we had was, what kind of, maybe you can handle this one, Aaron, what kind of expertise do you need to create a prototype?
So the idea of prototype is that it needs to be quick and have some immediate feedback, right? Immediate value. And I'd like to tell you that you need just all kinds of resources and all kinds of expertise in order to develop a prototype. But these are really, really easy systems. I think you saw an example of a board that was up there and had some circuitry built in and had some LED lights and some sensors attached to it. As you get into the final production phase, and you want these things to be perfect and 100% reliable and industry capable and weather certified, environmental certified, and not have dust protective coverings and all that kind of thing, then you probably do need some expertise, some real expertise. And so the final stage, you probably would need a mechanical engineer to help you design the casing so that it's environmentally controlled, the enclosure. You want to have somebody help you design how that's going to mate to your piece of equipment. You would need, in the end, you would need an electrical engineer, somebody to really develop a high productivity, very efficient set of circuitry, and the embedded code that gets developed inside of that, so it's very efficient. And then you would need a software developer to develop that integration. How are we going to get that data from one place to another through Wi-Fi or through some means of connectivity, store that in a database, and then build a dashboard? Well, that sounds all pretty complicated, right? But For a prototype situation, it's very easy. We don't need all those steps. We don't have to have a fancy enclosure. We don't need to care how it mounts and be concerned so much about vibration or those kinds of things. We don't have to have an electrical engineer that designs the embedded code to the most optimized state. We're just trying to get some initial data to prove out that in fact measuring humidity and temperature and flow rate and speed and some things like that, just to validate that in fact that has an impact on my manufacturing process. And as you prove that out in a prototype situation, then you can take it to the next step and say, all right, let's do this for all 35 of our machines, or let's take this to a production level. And to do that, it requires really I would say just an overall idea of what you want to develop, some acquisition of some very inexpensive circuitry, and then maybe one of our staff in conjunction with one of our customer staff to develop this prototype and install it and connect the Wi-Fi and collect the data. It's really pretty simple. In the end, you want to have a pretty professional process so that you can have very accurate data so that you know what you're looking at is good information. You can make good decisions, but developing a prototype is a really easy process.
Yeah, and the reality of it is if you're going to be making business decisions based on that, you want to make sure that that is accurate. And so then it takes a blend of skills, like Aaron said, between software, mechanical, and electrical. And we can provide those, or we can work with our customers to provide maybe the pieces that they're missing. But the overall thing is it's just some really cool technology that we think that everyone could be well served by implementing, because it's definitely the way everything is going for sure. I think there's a couple more slides here. We'll just kind of go through quickly on some upcoming things, and then if there's no more questions, then we can wrap up. Now we also have some packages for unlimited training, which is pretty sweet. So you can get as much training as you want for 12 months. Again, you can talk to our folks here, or you can just go on the website and inquire about that too. And also a user group that we've started on the Autodesk products. And so some cool stuff going there. We can all team our brains together to help everybody be better at what they're doing. And with that, there will be a little quick survey that pops out on the webinar to help us refine and provide more value and see how we did. And feel free to blast us or compliment us, whatever you feel is appropriate. And I think that's about it.
So we hope this presentation gives you some thoughts about the data that you can monitor in your organization. You can collect that, you can report on it. Applied Engineering is here to guide you through that process if you wish and help you develop solutions as needed. And in the end, really no matter the technology or the application, if there's a reason and a value to build this kind of a connection and this data, we're really here to help you with that process. So thanks very much for your time.
I hope you can enjoy the rest of the sessions of Applied Day over the next Applied 2 days.
Yeah.
Thank you.